Hello, in this video I'm going to solve the following problem for you, which is a problem on the topic of rational equations. Determine all real solutions of the following equation: x plus 1 all over x plus 2 plus x plus 6 all over x plus 7 equals to x plus 2 all over x plus 3, and finally plus x plus 5 all over x plus 6. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do the calculations correctly, you will get x is equal to minus 9 over 2. The interested students for more problems of this type can refer to the following playlist. The link to the PDF file that you can see on the display right now will be available on the description below this video. Okay, now let us solve the problem. Of course, this is a rational equation. The standard way of solving a rational equation is to find LCD, the least common denominator, between all fractions, all denominators, and multiply both sides of the equation by that LCD. This, of course, as you know, will help me to have an equation without any fractions. And the logic is that solving an equation without any fractions should be, in principle, simpler than solving an equation with fractions. Of course, if the problem becomes a little bit harder, you have to be wiser, because here it is very clear that the LCD between all these fractions is just the product of the denominators, which will be a fourth degree polynomial. If I take that one and multiply it here, yes, one of them will cancel this one, but three of them will be left. They have to be multiplied by the numerator. So then I will get four parentheses to multiply. And the same happens here, the same happens here, and the same happens there. Of course, it is doable at the end of the day, but you will see that the calculations will be heavy. So whenever this happens, you should be able to stop a little bit and then be able to think outside the box. So here the box is just simply follow the rules, multiply by LCD directly, which is a heavy which gives rise to a heavy calculation. So it is better to pause a little bit and try to find a better solution. Might be we will be able to find a better one. So for example, here, what you can do, you can move things around before doing that. Okay, so here you see that if I move this to this side, okay, so let me write it like this. I will keep the first fraction on the left, but I will move this fraction to the left. When I move it to the left, I have to make it negative, okay? And then on the right-hand side, I will keep this one, and then I will move this to the other side. And I have to make it, of course, negative. Okay, what was the reason I did it in this way? Because I was a little bit seeing ahead of me. I saw that if I multiply these two, then this 1 and 6 becomes 7. And if I multiply these 2 and 5 become 7 as well. And if I do the same thing here, so as you see, if I multiply them, because I will have x times 7, 2 times x in total, it becomes 9x. And if I do the same thing here, it will be 3x and 6x in total, 9x again. And because in this way I have a negative sign both here and there, I was hoping that things will get simplified because they will be the same. So that was the motivation I did it in this way. Okay? But if it doesn't work, then of course you have to cross it over and then find another way. But let us see and hope that this will work. And I will not go for the multiplication by LCD. What I will do, I take the common denominator just between these two. So the LCD between these two is just x plus 2, x plus 6. And then I compare this LCD with this first denominator. I see that I have an extra factor of x plus 6, which will be multiplied by its numerator. So it becomes x plus 1 times x plus 6. Then I have a minus sign. I compare this one with that one. I have this extra factor x plus 2, which will be multiplied by its own numerator. So it becomes x plus 2 times x plus 5. Okay, this is the left-hand side. I will do the same thing for the right-hand side. So let me just do it quickly. Okay, now when I expand these two and these two, you will see the first observation I made, meaning that the terms will cancel out, is going to work very nicely here. So let me expand the left-hand side. So I copy and paste the denominators, x plus 2, x plus 6. On the right-hand side, I will also have x plus 3, x plus 7. Okay, but now let me multiply these two. X times x is x squared, but x times 6 is 6x, 1 times x is x. In total, I will have 7 x's. And then when I multiply 1 by 6, it becomes just simply 6. And I will do the same thing here. So I have to expand and then multiply the minus sign within the all expressions. So I want to do it in one go. So x times x is x squared, then a minus sign will come in. So it becomes minus x squared. X times 5 is 5x, remember it. 2 times x is 2x. With that, 5x becomes 7x, and then another minus sign will come in. So it becomes minus 7x. And finally, 2 times 5 is 10, a minus sign will go in, so it becomes minus 10. So you see, it's very good because x squareds are gone, 7x's are also gone. I am just dealing with one number there. I will do the same thing here, okay? So x times x is x squared. X times 7, 7x, 2 times x, 2x, in total 9x's. And then I have 2 times 7, which is 14. And then the same story here. I multiply this, and then I put the minus sign for all the terms within. So x times x is x squared. With that minus sign is minus x squared. I have x times 6, 6x, 3 times x, 3x, in total 9x, with a minus sign, minus 9x. And then finally, I have 3 times 6 is 18, with a minus sign, minus 18. Yes? And now you immediately realize that what happens, this x squared and x squared are gone, 7x and 7x are also gone, 6 minus 10 is just minus 4, and the denominator is the same. And then what happens here, x squareds are gone, this one is also gone, and then 14 minus 18 is also minus 4, so I'm very lucky now. Yes? Okay, so now I have one fraction on the left and I have one fraction on the right. They are supposed to be equal. The good news is that the numerators are the same. So if these two fractions are supposed to be equal, because the numerators are the same, the denominators have to be the same as well. So this means this should be the case. And then you see that this is an extremely simple equation to solve. Okay? Because if I multiply it, it becomes x squared, 6x, 2x is in total 8x's, 2 times 6 is 12. On the right-hand side, I will do the same thing. X squared, 7x and 3x becomes 10x, and then 3x, 3 times 7 is 21. And then it's still, you see that x squareds are also gone. And then I move 10x to the left, 8x minus 10x is just minus 2x. And I move 12 to the right, 21 minus 12 is 9. And I calculate x, and it becomes minus 9 over 2. But of course, you know that in rational equations, before accepting this, because sometimes there is a chance that you have a false root, okay? You have to make sure that this one is not a false root, but of course it is not, because if I refer to the original equation, I see that x equals to minus 9 over 2, which is minus 4.5, will not make any denominators equal to 0. So that is indeed a solution, not a false solution. Okay? So this example is instructive from this point of view that, of course, when we teach during the lessons, I will give you the methods that usually works. but the questions on a higher level are somehow designed in a way that if you just want to follow blindly what you learn in the classroom, it will pose a lot of problems. I haven't done it myself, yes, in the normal way, but you can. I doubt that it is not possible to do it. It will take a longer, much longer time if you want to solve the problem using the method of multiplying both sides by LCD. But my impression is that this is doable, but it takes much longer time. Okay, so might be that is also a good idea to check the recent model of ChatGPT, so O1 preview, because I have the plus version to test this model. So I have already typed the equation here in LaTeX format, okay? And I want to see how ChatGPT O1, which is claimed to be at the level of PhD in physics or mathematics, will solve the problem. Okay, so let us just do this prompt and see how it works. So you can also open and see what it is doing, and then it finally finds the answer. Okay. Okay, so let us review a little bit to see what it does. Okay. So it also grouped this in this way, so it understands that it is better to group it, but of course it moved everything to the left-hand side. Okay? But the grouping was different from mine, yes? X plus 1, X plus 2, and X plus 2, X plus 3 is probably also another good choice, yes? Because if you do that, then it becomes this will go here, X plus 1, X plus 3, and then this will go there. It becomes X plus 2 times X plus 2, of course, which is X plus 2 to the power of 2. And then when ChatGPT simplifies this part, then it gets this answer, and it will do the same thing for this combination, yes? And after all those simplifications, ChatGPT will get this answer. And now this will take these two and put it back into the equation, okay? Exactly like this, and then move it to the right. And then this equation that ChatGPT gets is different from mine, but the solution is different. But the good news is that it realized that it also also needs to work outside the box, yes, by doing this grouping, which is different from my grouping, but it actually follows the same rules. Okay, so I hope that you also enjoyed to see how ChatGPT new model solved the problem. Okay. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.